Hello. Hello. So in this lecture, we are going to discuss about another interesting topic of digital electronics, that is programmable array logic or PAL. Programmable array logic. Okay, so in this lecture, I shall show you what are the steps you need to follow to implement some function by using PAL. Okay. So first of all, you need to understand what are the things are required to implement PAL. So like PLA, in this case also, three things are required. One is input buffer that you need to decide according to the question, and programmable AND gate. So programmable AND gate, as it is written as programmable, you have to use cross sign to do the connection, and you have to use fixed OR gate. So fixed means you need to use this type of connection by this type of dot. Okay. You need to do the connection. Now, what type of connection you need to do, that I will tell. Suppose these main terms are given, which you need to implement by using PAL logic. X, Y, Z. Suppose the main terms are given as 0, 1, 3. And the other function F2 is given as main term of 0, 3, 4, 6. Now suppose these two functions are given and you need to implement it by using a PAL circuit. Now how to implement? So first of all, what you need to do, step number one, you need to do the minimization. So this is step number one. You need to do the minimization by using KMM. If it is possible, then you just try. You just check whether it is possible to do the minimization or not. If it is not, whatever expression you'll get using this minterm, that only you need to use. And if it is minimization is possible, then we'll do the minimize. We'll use the minimize expression. Now, try to find out KMM X, Y, Z, 0, 0, sorry. 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Now do the indexing. 0, 1, 2, 3, 4, 5, 6, 7. Okay. Now check the first function. So that is 0 here, then 1 here, then 3 here. Okay. So we can do here one pair. So if we do this pair, then what expression will get from the left side is X bar, from the top it will be Y bar. Okay. Now for this pair, what we'll get from the left side X bar, from the top this is Z. Fine. Now similar type of things we need to do for the F2 function. X, Y, Z, 0, 1, 0, 0, 0, 1, 1, 1, 0, F2. The indexing we have already done in the previous case. No need to do further indexing. So this is 0th position. Then this 3rd position. Then 4 is this one. Then 6 is this one. So these two we can combine to make some pair. Okay. So what will be the result if you combine these two? From the top it is y bar, z bar. Fine. Then if we combine these two, this one and this one, what will get? X, and from the top it is z. Okay. That is, we'll get x, z bar. And this we cannot combine to anyone. So this is separate component, that is x bar, y, z. Okay, so these are the components we are going to get. Now, step number 2. Step number 2, what you need to do? You need to decide the number of input buffer you need to use. So that is, how many variables are given in the question? 3 variables, we need to use 3. Okay, so the number of input buffers is equal to the number of variables given in the question. That is x, y, z. So 3 variables are there. It means that we need to use 3 buffers, input buffers. Now come to step number 3. In step number 3, what you need to find out the number of AND gate or programmable AND gate, the number of programmable AND gate. So the number of programmable AND gate is depending on the number of maximum min terms given in the problem. So you see, in this problem, 2 functions are given. F1 is one of the functions, F2 is the second function. So in case of F1, you got 2 min terms. F2, you got 3 min terms. So you need to take the maximum one. Okay. So how many AND gate you need to use? Programmable AND gate, that is given as number of function given in the question into maximum number of min term in a function. Maximum number of min term in a function. So you have 2 functions, and in one of the function, that is F2, you have 3 number of min terms. So it means that you have to use 3 number of min terms. Okay. So this is the minimum of maximum number of min terms in a function. So in this case, how many min terms are there? 2 min terms. In this case, how many min terms are there? 3. So out of 2 and 3, which one is maximum? 3. So we need to use 3 terms for this part. And for this part, how many functions are given in the question? 2 functions, F1 and F2. So 2. So it means that 3 AND gate unit, 3 into 2, 6 AND gates you need to use. Okay. Then you need to decide the number of fixed OR gate. Fixed OR gate. So the number of fixed OR gate is nothing but the number of function given in the question. So in this question, 2 functions, F1, F2. So 2 functions means 2 OR gate you need to use. Okay. Now what you need to do? You have to do the connection. Okay. So everything you got, now you need to do the connection. So first you start from the buffer part. So how many buffers we have calculated? 3 buffers are required. 3 input buffers are required. Okay. So you have X. This is your buffer. It is having 2 output. One will give you the original variable. The bubble part will give you the inverted portion of that variable, inverted value of that variable. Now you have Y. Here also 2 outputs. This will give you Y bar. This will give you Y. And Z also. 2 outputs are there. This is Z bar. This is Z. Okay. Now after that, what you have found out? How many AND gates you need to use? Because in the beginning itself I told, in programmable array logic, 3 things you need to use to implement any function: input buffer, programmable AND gate, and fixed OR gate. So input buffer, we have found out these 3 numbers. Programmable AND gate also you have calculated, that is also 2 into 3, 6 numbers. So we need to draw these 6 numbers of AND gate. 1, 2, 3, and 1, 2, 3, total 6. Okay. So 2 such pairs are required, and each of the case 3 AND gates will be there. That is maximum number of minterms in a function, that is 3. So 3 AND gate will be there, and such 3 combinations you need to do 2 times. So that's why total number of AND gates are 6. So what I'm trying to say, this one AND gate, this one AND gate, this one programmable AND gate. So these 3 is making some pair, and these 3 is making some combination. So these 3 is for function number 1, and second 3 is for function number 2. Okay, this way also you can try to understand. Okay, so what you need to see, you need to check how many AND gate you need to use in each of the combination and how many such combinations are there. So how many number of AND gate you need to use in a combination, that is depending on the maximum number of minterms in a function. Okay, in this case it is 3. And how many such type of 3s you need to use? 2 such 3s you need to use. Why? Because the number of functions are 2. So you have taken 3, 1 combination, you have taken these 3, 1 combination, 3 plus 3 is 6. Okay, now this programmable AND gate means we need to get each of the things. So first function is x bar y bar. How to get x bar y bar? This is x bar, this y bar. So this AND gate will give you x bar y bar. And the next AND gate has to give x bar z. This is x bar, this is z. Okay, this connected to the inverted line means this is x bar, and this is connected to the main line, this is z. So this is giving you x bar z. Okay, this is giving you x bar z. What about third one? Third one you no need to use because the third function is missing, or there is no third minterm. Actually, there is no third minterm in the first function. So you no need to use the third one. This cross. Okay, no connections will be done for this one. Now come to the second combination. For the second function, you have to get y bar z bar. So y bar z bar is, this is y bar, this is z bar. So this is giving you y bar z bar. Then next one is x z bar. So this is x, this is z bar. So this is giving you z bar. And what was the third component? The third component was x bar yz. This is x bar, this is y, and this one is z. So this is giving you x bar like z. Okay. Now what you need to use? So buffer you have already used, AND gate, programmable AND gate you have used. Now you need to use the OR gate. How many OR gates you need to use? 2 OR gates that we have already found out. And for OR gate you need to use the fixed connection. Okay. That is the property of your programmable array logic. Okay. So this is the first OR gate, which will give you the F1 function. So F1 function means you have this x bar. If you can remember, what is the F1 function, which is having x bar y bar and x bar z. So this is x bar y bar. We have made this fixed connection by this dot, and x bar z this line. Okay, and third one is not used in this case, but still we need to do the connection, and we are not getting any connection for the third AND gate, but still we need to fix it because each of the function has to be implemented by these 3 AND gate that we have found out. Now this is for F1. Now what about F2? F2 was Y bar Z bar. This is the connection. Then X Z bar. This is the connection, and X bar Y Z. This is the fixed connection. So fixed connection, you have to use this dot type of thing. So this is for Y2. Sorry, F2. So this is the way to implement functions by using programmable array logic. And these are the steps you need to follow. Thank you.